Hi everyone, so today I will be discussing about the inferring wave property from the sinusoidal wave. So our topic is about sinusoidal wave. So what is sinusoidal wave? Sinusoidal wave is the wave function can be described with the various properties of wave. From its mathematical form, we can extract physical quantities such as speed, wavelength, frequency, period, direction, and wave number. So in simple words, sinusoidal wave is a wave that keeps repeating the same motion up and down over and over again. So this video presenting in front of you is an example of sinusoidal wave. So as you can see, it has a continuously repeating up and down motion that will continuously until it reaches the final point of the wave. So the formula for sinusoidal wave is y of x and t is equals to amplitude sine times k x minus omega t plus pi. A for the symbol of amplitude, k for the wave number, omega for the angular frequency, and pi as phase constant. So let's start with the amplitude. It is the maximum disturbance from the crest of the wave from its rest position. It represents the wave height. So crest is the highest point of the wave, while the trough is the lowest point. This means that the amplitude is the maximum height of the wave from its rest position, or the middle line. For example, in sound wave, a large amplitude means the sound is louder, while the smaller amplitude means it's softer. So the unit we will use for amplitude is meter. Next is wavelengths. Wavelength is the distance between two consecutive crests or trough. So wavelength is the distance between two similar points of wave. For example, is from one crest to the next crest. So for example, if the waves are closer together, that means a shorter wavelength. So if the farther part, that means a long wavelength. Next is frequency. So the frequency is the number of oscillations per second. So the frequency tells us how many waves passes a point per second. For example, if a wave passes 10 times every second, it means that its frequency is 10 Hz. So high frequency means the waves are fast and close together, while the low frequency means they are slower and far apart. So in solving the frequency, we'll use the F is equals to 1 over T. Next is wave speed. The speed of a wave tells us how fast it moves through space. So we can find it using the formula of V equals wavelength times frequency. That means if we know the wavelength and frequency, we can calculate how fast the wave travels. For example, if a wave has a wavelength of 2 meters and a frequency of 3 Hz, it moves at 6 meters per second. Next is wave number. The wave number gives the spiral frequency of the wave using the formula of 2 pi over wavelength. It indicates how many wave cycles fit into unit length. So if the wavelength is short, the wave number is large, meaning more wave fit in 1 meter. Next is period. Period is the time taken from the one cycle. So the period is the time it takes for one complete wave to pass. It's the opposite of frequency. If the wave repeats 10 times each second, that means each wave takes 1/10 of a second or 0.1 seconds. So when solving the period, we will use the formula of T is equals to 1 over frequency. So at this part of the lesson, we will see here the formula we will use for the different direction of the wave. So if the wave travels at the positive x, the direction is at right, while when the wave travels in negative x, it is moved to the left direction. So at this part of the video, I will be giving an example on how to solve the wavelength, wave speed, and swap frequency. So for my first example, you're listening to your favorite song on speaker. The sound wave coming from the speaker has a frequency of 440 Hz, and the speed coming from the air is 340 meters per second. Find the wavelength of the sound wave. So the given is wave speed is equals to 340 meters per second, and the frequency of 440 Hz. The required of this problem is the wavelength. So in solving this, we will use the formula of length is equals to wave speed over frequency. So in solving this, we'll just write it down. 340 meters per second over 440 Hz. So we will use calculator for the answer. So 340 divided by 440 is equals to 0.077. We will use the nearest hundreds. The answer is 0.77 meters for the first example. So for our second example, we will find the frequency and the wave speed. So in this example, you're chilling in a swimming pool. Then you gently move your hand back and front of the water surface. You notice small waves spreading outward. Let's say that the distance between the two crests is 0.5 meter, and each wave passes your hand once every 0.25 seconds. Find the frequency and the speed of wave. The given for this is the wavelength of 0.5 meter. And then the point or the set time for 0.25 seconds. Then the required for this problem is the frequency and the wave speed. So in solving this, we will use two formulas. First is the formula for the frequency. In F is equals to 1 over period of T, and wave speed is equals to wavelength times frequency. So we use it to solve. Frequency equals 1 over 0.25 seconds is equals to 4 hertz. Next is for the solving for the wave speed. So wave speed 0.5 meter times 4 hertz is equals to, using the calculation again, and it is equals to 2 meter per seconds. And that's all on solving the wavelength, frequency, and the wave speed.